Aloha, Richard Halverson here. This is ITS128, and today is October 29th. Let me share my screen. So share. Okay. And I just want to make sure that hold on. I'm just gonna make sure this is the right. Okay, this is the right. Oh yeah. That's right. Okay. All right. So let's get started. I'm gonna share my screen. Sorry about that. Okay. So here we are. Wrong class. Syllabus. Okay, so we are. Let's see where we left off last time. 620, 6.20 looks like. Okay, so let's go back to just a curiosity, see where that is. We're at the end of October, and we should have started chapter 7. We're finishing up chapter 6. That's fine. That's fine. So let's go to 621. Step count. Okay. A pedometer treats walking one step as 2.5 feet. Define a function named feet to steps that takes a float as a parameter representing the number of feet walked and returns an integer which represents the number of steps walked. Then write a main program that reads the number of feet walked as input, calls the function, and outputs calls the function with the input as an argument and outputs the number of steps. Okay, so so somebody inputs this is how many feet I walked, and it's going to output the number of steps because this divided by this equals this. Okay, so you can check that with your calculator. This divided by this. So this is the number of feet. You divide by the steps per feet. So you divide by the feet per steps. Yes, you divide by the feet per steps, and then you end up with steps. Okay, good. All right. So let's try to write this function. So you're gonna and it's got to be called this. So we might as well just copy this over. Okay, so now it says that we should use floating point arithmetic to perform the conversion, and the conversion is right here. So I'm going to do something like steps equals user feet divided by the number of feet per steps, which is 2.5. 2.5 feet per steps. 2.5 feet equals 1 step. So we have feet. We're going to divide by feet per steps, and we end up with steps. Feet divided by feet per steps equals steps. Okay, remember that. It's algebra. Inverting and so on. Okay, so and then we're going to return this. Now, steps has got to be an integer because you're not going to take part of a step. I think, does it say it's got to be an integer someplace? Well, this is an integer. Oh, okay. So what is 150? What is 150.5? 150.5 divided by 2.5 equals 60.2. 60.2. So that means that we are integerizing it. So we have to int it. So we want to convert this into an integer. So let's just make steps be an integer to begin with. And this still calculation is still done in floating point. And so I'm just going to say int this. I'm going to say integerize this. And now I'm returning an integer. Okay, so now I'm just going to read. I just have to read user feet. User feet equals an input of some sort. Asking the user, and then we need to float it. So we need to float it, and so we can float it this way, or we can say user feet 2 equals float user feet. It doesn't matter. I'm being sloppy, but I'm just trying to make the point that, you know, sometimes it's confusing if we're just to put an int around here. You know, I mean, I'm in a float. We can just do this. We can just do this, but that can be confusing. So so you know, I'm going to break it down to the basics. And first we read in something, and then we convert it to a floating point number, and we're calling it a something different. And then we're going to do we write it out? Okay, so so I can say steps equals feet to steps of this, because that's what was read. No, yeah. That's the argument. And then we print steps. Okay, so so let me just I'm going slow here again because let me go to replit. Is this my replit? Yes, it is. There I am. So I'm gonna go to my replets, go into my test thing here. Oh no, let's go into this one since we're actually doing labs now. And I'm going to make one for 6.21. This one. And I'm going to call it 6.21 lab feet to steps or some stupid thing like that. And I'm going to paste this right in here just because I want to go through it and we can step through it. And I've done some things that some people might ask about. And that is, you know, I'm using this as a variable up in the function, and I'm also using it as a variable out here. They're two different variables, okay? They happen to be the same thing, but it's here. I'm going to tell you what. I'm going to be fancy here, just to make the point. I'm going to not integerize it here, okay? And that's going to make steps be a floating point. Now it's still a floating point number because we have a floating point number divided by a floating point number, and this is a floating point divide. 1 slash, 2 slashes would be an integer divide. And so this is a floating point number, and but I got to integerize it. So I'm going to do this int, and this makes it an integer just before it's returned. Now when it comes, this is an integer because this returned an integer. So this is an integer, and now we print it out. By the way, let's see if this works. Let's run this first, and we'll put in 150.5. It's asking me, right? 150.5 feet. That's how far I went. It returns 60. Okay, so just so we can see this working here, I'm going to put a breakpoint right here, and then after that, I'm going to step through it. So I go run, and now it's stopped at the breakpoint, and it's probably waiting for me to type something in because the previous one was executed. So I'm going to type, I'll just type the same thing, 150.5. Okay, and I'm going to hit enter because that's entering it. And now we've hit the breakpoint because it was, before it was stalled up here because I had to type something. Okay, so we hit the breakpoint, and now we can look at our variables. We're at 9, and we're at 9. See right here, that 9. And we have a variable called user feet, and it is a string, and that string is 150.5. And now let's do a step. And now we've got a new variable called user feet 2, and that is the value, the floating point value, 150.5. See, it's converted from a string to a floating point value. And then now when I hit this, it's going to call feet to steps, and now we're up here. You can see we're on line 3. We're in feet to steps, and we've just passed in this user feet, and so we've got user feet here. And it's a floating point value of 150.5. And so let's go to the next one. And now we have a new one called user feet. No, we have a new one called steps, which is 60.2. It's a floating point number. Steps is a floating point number. When we return, we're going to return, we're at 10. And we're outside. Where are the rest of our variables? We're out. These are the rest of our variables. User feet is still 150. User feet 2 is still 150.5, and we haven't executed 10 yet. We're about to execute 10. So steps does not exist yet because we haven't executed it yet. Let's execute it. Boom. And now 10 has been executed, and now steps gets set to the value 60. Remember up here it was 60. Anyway, so it's an integer, and then the next thing is we print it. And there over here it's printed, and we're done. Anyway, so that's probably what the answer is for that. You can just type submit thing. All right, what's the next one? Let's see. Okay, Jiffy. Jiffy is the scientific name for 1/100th of a second. Given an input number of seconds, output the number of jiffies. I suppose we're going to have to say jiffy and jiffies, take care of the plural and everything. Is that true? What is a jiffy? Is that how you spell it? Oops. Oh, I'm sorry. Of course not. What is a jiffy? Oh, is a jiffy 1/100th of a second? All right. I guess it is. Okay, so anyway, sorry. Okay, so we're supposed to input the number of seconds and output the number of jiffies. Don't we just have to multiply by 100 or something? Output each floating point value with 2 digits after the decimal point. So we're going to use this format, 2 digits, floating point number, 2 digits to the right of the decimal point, which can be achieved this way. And this is going to be our jiffies, whatever your value is. So we input this in minutes, in seconds, and we output 100 times that. Boy, this looks really difficult, doesn't it? You know, I think I should just let you do it. But you got to make sure that you're printing. You want to print using this format. So, so you got to start by doing this. Copy, and you want to paste that here. And colon, and then you want to return. You want to figure out how many jiffies it is, equals something. And then you want to return jiffies. Okay, so you want to do that. And I'm just going to say, you want to figure out what the formula is. It's this times 100. Okay. So put that here, put that expression there. I'm just going to put 0 there, but you fill that in. Okay, so this computes the jiffies, and then you just have to read in seconds, you know, and I suppose it's an integer value. Must be an integer value. You know, integer value of input. And then after that, you're just going to print out, you're going to print this somehow right here. And I would put, well, you can just be lazy. You put seconds to jiffies, seconds or something. See, because this will call the function, and in place we'll put what is returned. So this calls the function, computes the number of jiffies per second, or for how many seconds you entered, and it'll replace this thing here with whatever the value is, and then it'll print it out. So you have to fill in this thing. Fill in expression. Sorry. Anyway, this is easy. This is such an easy. Oh, leap years. Another leap year one? Well, you should just go back to your old leap year program, because I noticed that we've had this before. Let me see what. So I guess this time we're making a function. Oh, def is. Oh, okay. So the input is the year, and we're going to output a true or a false. We're going to output, yes, it is a leap year, or no, it's not a leap year. Oh, that's what the function is going to be. And so, you know, we're going to input a year, some year input, but it's got to be an integer. Int year, it's got to be integer. I'm being sloppy when I'm doing this, just to make the point that you know, you can put things inside of parentheses, or you don't have to. Actually, I'm done making that point. I'm just going to do this. Int. So this is going to ask the user for a year, and then it's going to output. This would be a good one to do on Replit. This is going to be 6.23. Let's do. I want to go here. Make a new one. What do I do here? 6.23 leap year. Again. Okay, so all right. So the first thing we got to do is we have to have a function where we read in a year, and it's an integer, and if is leap year, if that is, and we enter that in here. So this is going to return a true or false, and that's the function we're going to write. Def is leap year, and we're going to input some kind of year. Okay, so we ask the user for a year, and then we call is leap year with the year, and leap year is going to return a true or false. If it's true, we're going to say print, you know, I don't know, year is a leap year or something, whatever we're supposed to print. Or if it returns a false, just go like this and you print year isn't. Uh-oh, we got to do something about that. We can put a backslash in front of it, or we can use quotes. Actually, I like using the opposite one, so isn't a leap year. There we go. So, so this is probably done. We just have to, you know, write this function. So, so we have this value coming in called year, and first of all, let's see if year is divisible by 4. If it's not divisible by 4, it's not a leap year. It's moved, end of story. So, if year, what time is it? Can you hold on a second? I have to go take something out of the oven. All right, so we are gonna look to see if year mod 4 is it equal to 0? If it's not divisible by 0, if it's not equal to 0, yeah, that's the right operator for not equals in this language. So if the year is not divisible by 4, then we can return false. Capital F. Okay, there. And then we're done. So if it hits that, it returns, and everything else is ignored. So we don't need to do an else. So we don't even need to do an else because what's going on? Enter. Okay. So we can just go right back to here and continue on our merry way. So now when we're here, we know it's divisible by 4. So let's see if it is divisible by 100, because if it's divisible by 100, then it is a leap year. It's divisible by 100, it's a leap year. Oh, no. If it's not divisible by 100, it's a leap year. It's only if it's divisible by 100 do we need to do some further analysis. Okay, so it's divisible by, if we're here, we know it's at least divisible by 4, and then we could say if y is if y mod 100 is not equal to 0, then we know it's not divisible. Oops, I gotta put equal sign. Not equals 0. Then we know that the year, for at this point, we know the year is divisible by 4, but not divisible by 100. So we know it is a leap year because if it's divisible by 100, then we got to go check to see if it's divisible by 400 before we know it's a leap year. So I'm just going to return true, because if it's at this point, I know I'm already know. And so now, oops, enter. So now I'm back here. If I'm at this point, if I get all the way to this point, I know it's divisible by 4, and I know it's divisible by 100. So I better check to see if it's divisible by 400, because if it's divisible by 400, then we know it is in fact a leap year. But if it's divisible by 100 and not divisible by 400, then it's one of those funny years that it's not a leap year. So like, you know, 1600 was a leap year, but 1700 wasn't, 1800 wasn't, 1900 was not a leap year, but 2000 was a leap year because 2000 is divisible by 400. All right, so if y mod 400 is well, this is the as low as we go in the nesting. So I can say if y mod 400 is equal to 0, then we know it is a leap year. Return, yeah, it's a leap year. 2000 was a leap year. True. Otherwise, return false. Okay, so code. So if it makes it to here, then that means we did not return. That means we did not. Well, if we make it here, then we know that y is divisible by 4, because if it was not divisible by 4, it would have returned. And then so here we check to see if it's divisible by 100. If it's not divisible by 100 at this point, it is divisible by 4, but it's not divisible by 100. So we know it is a leap year. We know it's no special kind of year. Here we check to see if y is divisible by 400. Okay, if we get to this point, we know that y is divisible by 100. So now we just have to see if it's divisible by 400, because if it is, then it is. Okay, so anyway, I think this will work. Let's try some. I'm going to ask, enter a year. I'm going to ask. And let me see what they suggest as things to try. 17, 12, 19. I'll just try. Okay, so let's run this. Enter a year. 1712 is a leap year. Is it a leap year? I guess it is. 1913 is not, obviously. 1915 is not. How about 1900? Yes, that's right. What about 2000? Yes, it is. Okay, anyway, I think this will work. And I bet it's different than what you had. So, all right, so let's go to the next one. Yes, I can. Convert to binary functions. Okay, so in this code, take a program, write a program that takes a positive integer as input and outputs a string of ones and zeros representing the binary integer. For an integer x, the algorithm is, as long as x is greater than 0, output x mod 2, and then divided by 2. Okay, so okay, so I'm gonna okay, this is a good one for Replit, and I'm gonna actually step through this one with Replit because it's one of these iteration things. And this is 6.24. So I'm gonna make a new Replit. Is there an easy way to step back? Can I just go back to here? No. Still getting used to this navigating Replit here. I'm going to create a 6.24 convert to binary. Okay, so we're going to need, we're going to create a, oh, is that how we're going to do it? We're going to create these two functions here, I guess. We're going to create these two functions. I'm going to say this colon pass, just to get them in here. Colon pass, and then the main program is this. Okay, and this is the algorithm. As long as x is greater than 0, and this is converting. Okay, so integer to reverse binary. Okay, so we get an integer in here, and then we're going to convert it to binary. But it's going to end up being reverse binary, and then we're going to run this reverse string function to reverse it to so it looks like a regular binary string. And we'll see how this works. So first of all, we're going to ask the user for an integer. I'm going to call it base 10. It's a base 10 number. Equals I'm going to do real sloppy here. Base 10 string equals input, enter an integer, colon. Okay, so it's going to do that. And then I'm going to say so it's going to be a string. Then I'm going to say base 10 integer is equal to int of base 10 string. Okay, so now I've got a base 10 integer. And then I'm going to call this reverse, I'm going to call this integer to reverse binary function. So I'm going to say, reverse binary is equal to integer to reverse binary, parentheses, base 10i. So it's going to take in this integer number that you typed in, and it's going to convert it to a reverse string binary. And then I have to say binary. I'm going to say binary. Can I just, okay, that's not a reserved word. Okay, binary equals reverse. Oh, by the way, this is a reverse binary string. So I'm going to put that. I'm going to say string. And so that binary is going to be binary string. It's going to be this function that we created, reverse string of this reverse binary that we got back from the other function. So that will give us our binary string, and then we can print it. Print binary string. Okay. All right, so we got that. Now let's write some functions here. So I'm going to start. I guess I'll start by doing this algorithm here. So we've got this integer value here. Okay, that's a perfectly fine variable name. And let's get rid of the pass. And I'm going to say, I can use integer value. So I'm going to say, okay, so output string equals nothing. And then I'm going to say, if integer value mod 2 is oh, I guess I can just, oh, I don't have to do if, do I? I can just say digit equals integer value mod 2. What's going on? Oh, no, I don't. Yeah, right. So I have, what's the matter? Why is it giving me grief? Oh, it's assigned but never used. Well, I haven't used it yet. That's why. Okay. And this is going to be, this is an integer, so I got to convert it to a string. So I'm going to say output string, append onto output string. This is a you still use a plus sign, but we're doing strings now, so it's going to append it onto the end. Append onto it the string version. I'm going to be simple again. Digit s, the string version of digit, equals string of digit, and then output string plus equals digit string s. Okay, so and then I'm going to say this integer value here. I'm going to do this here. So this is integer value equals integer value integer divided by 2. Okay, so that does that. Now this is a loop while integer value is greater than 0. So we got to do a loop here. So let's integer value while integer value is greater than 0. Then do this modular operation. So that's like right up here. While integer value is greater than 0, then do this stuff. Do this and do this and do this and do this. And of course, this is what you got to worry about. Inside the loop, I am changing integer value, and it's getting smaller. It's going to keep on getting smaller because I'm dividing it by 2 each time. So this is going to eventually get to, this is going to eventually going to reach 0. And each time we go through the loop, we append the digit that we created onto this output string. And then, so once we're done, we can, and we would do it in there, return output string. Okay, and then so that's going to compute our output string, and I'll tell you what, I'm just going to do this. I'm going to say a return input string, just because I want to just see what it says. Okay, so I'm not going to bother. So I'm just going to do that. So I'm not going, when I call this function, I'm not going to reverse the string. I'm just going to return the string because I want to test the part up here. I want to test to see if when I do this, I get, why am I getting, oh, output string. It doesn't know what output string. It's obvious what output string. It's obvious what I meant. That's the point. There we go. Now the red squiggly is going. Okay, so I'm going to run this, and I know that didn't ask me. So I know that 1011 is 11. So 11 in binary is 1011. I happen to know that. 11 in binary is 1101. See, it's reversed. See, let's and see what else. What's this? 20 in binary is 10 10100. 20 in binary is 10100, I think. 20. And so the reverse is, yeah, 10100. Okay, so the reverse is that. So now we have to write, now let's write this reverse thing. So, I don't know why let's do it this way, because you know why? You know why it's dumb? Because I can just do this. I can do this. Okay, I just do that, and guess what? 20. 10101. See, instead of appending it onto the end, I stick it on the beginning of the output string. So I actually build the output string the way we're computing it, you know. But they don't want us to do it this way. In fact, if I so let me I'm gonna try to just to see what I get. I better take this out of there. I'm gonna now it's not gonna give me all the points. You know why? Because it actually unit tests your modules. So let me try to put this in there and see what I get. Okay, first of all, it should run. I'm gonna do 6. I'll put 6 in there, and I run it, and I get 110. And so now I go to submit and see what I get. Oh, I got a 5. Oh, this doesn't work. Everything else seems to work, but this doesn't. Oh, I bet you it's integer reverse. Yeah, okay. I wonder why it didn't test. Okay, well anyway, of course it didn't work because I didn't do it the way they asked me to do it. I gotta not do this smartass thing, and I gotta do it the way they want. So here's what I'm gonna do. I will go back to, where's my reference? Oh, here it is. I'm gonna show you how to reverse. Do you know how to reverse a binary string? It's something like that. Reverse equals nothing. For character in input string, rev equals character plus rev, which is basically what I'm doing here. I'm appending it onto the beginning of the string, and then I return rev. Okay, so that should reverse the string. This is going to loop through each character in the string, and each time it's going to append it onto here. Now, I'm mixing characters and strings, but I think this will work. Let's just try it. I'm going to put this back with the way it was. So now I'm appending it onto the end, and then I'm going to call reverse string. It should reverse it. So 20 should still give me 10100. Oh, it's I took out the asking. So 20, and now it's 1. Okay, so this works. Okay, so you know, this works. So let's move on to the next one. Swapping variables. This is another dumb one. Write a program whose input 2 integers and output is the 2 integers swapped. Okay, so we have to write this thing, and we're going to read in two integers, and we're going to output them in reverse. sure sounds like a tough one. But the point is that we make that we have to make this method, and it's going to go test the method. Okay, so we have to write this method. So let's just copy this over here, and this is 6.25. So let me create another replet. Why? Because I just like to. .25 lab. This is what do we call this? Reverse integers or something? Something like that. Whatever it was called. Swapping variables. Oh well.
Yeah, it's a swapping.
Whatever. Okay, so can I change it?
Yes, you can change it right there.
Right here?
Yes, yes.
Okay. I don't want to. What do we do now? Oh, okay, it's changed. Okay. All right. So so we have to create something. We have to create this method. Okay. And then we have to read it in. Can't I just do this? I don't know. Oh, I got to do this thingy. Oh, I should commit this to memory. If 2 underscores name, there's a 3 underscores, 2 underscores. If the name of the main program is equal to this main, then we're in business, and I want to ask for 2 integers, two variables. V1 is equal to integer of input. I'm going to say V1 just to make things easier for myself. And V2 is equal to int of input. I'm just going to have a little prompt here so I know what's going on. And then I want to I don't know. Can I do something like V? I don't know. Oh,
I just put A, B, and then I swap it.
yeah. Use, swap values of V1 and V2. Is that one? Is this all it is? I mean, this is print. And these are going to be values coming back, so I guess we got to stringify them. O1, comma, str, O2. Let's see what this does, if it works. V1 is 12 and V2 is 15. Wonder why I printed 2. Oh, it's because I did put a 2 there. V. All right. I wasn't passing V2. I was just passing 2. And so, of course, it's going to put 2 there. So now if I run it, 56, 32, 32, 56. This just doesn't seem right. It just doesn't seem like it should be that easy. So I'm gonna see if it's actually that easy. This is too easy. And I'm gonna get rid of the prompt. All right, what's next?
Why do we need the str, the string, in front of when you print? Why do you need that in front of the val1 and val2?
Maybe I don't.
I'm just wondering because
I don't think, yeah, you might not, if I was gonna like append it onto some other string, you know, then I would need that, but let's see.
Oh, I see. Okay.
This should definitely work.
Yes. Okay. I'm just wondering if I do something wrong here.
Yeah, good. Oh, Josie, thank you. Josie's on it. Thanks. Josie pointed out that I didn't have the V there. Okay, so I'm gonna submit this, see if this works. This is too easy. All right.
Thank you so much. We'll see you tomorrow.
Yep.
Thank you. Bye-bye.